Find the radius of convergence for f of x equals sum n equals 0 to infinity, x minus 2 to the n plus 1 over n plus 1 times 4 to the n plus 1. So the typical technique for finding the radius of convergence is to look at the ratio test. So what we have to do is take the limit as n goes to infinity of absolute value x minus 2 to the n plus 1 plus 1, or the n plus second term, divided by the n plus 1 plus 1, or the n plus 2, factor in the denominator, 4 to the n plus 1 plus 1, 4 to the n plus 2, multiplied by the reciprocal of the nth term. So that's going to be n plus 1, 4 to the n plus 1, over x minus 2 to the n plus 1. Now, of course, we factor some of this out and simplify. Let's take a little bit of a shortcut. So 4 to the n plus 1 is going to cancel with 4 to the n plus 2, just leaving us with a 4 in the denominator. Likewise, x minus 2 to the n plus 1 is going to cancel with x minus 2 to the n plus 2, leaving us a factor of just x minus 2. The n plus 1 and the n plus 2 are going to stay. Remember, we're running the limit as n goes to infinity. X minus 2 and the 4 in the denominator do not have any factors of n in them, and so essentially we can take those out. X minus 2 an absolute value over 4, or times 1/4 even, limit as n goes to infinity of absolute value n plus 1 over n plus 2. And as n goes to infinity, since we have the same degree in n, we look at the coefficients, which is 1 and 1, which equals 1. So this gives us an answer of 1/4 absolute value x minus 2 times 1. So by the ratio test, we're going to have convergence whenever our limit is less than 1. Equivalently, or absolute value x minus 2 is less than 4. We were asked to find the radius of convergence for this power series, and so 4 is the radius of convergence. Radius of convergence is 4.